I have prepared a new notebook for um, the raster plot. So I'm studying by using the histogram. So I will use the histogram for this. So I am starting it from here. So this will create a histogram. So we can see the data like from 300 to 400, and the values, the count are like 5,000 to 100,000 and 150,000. So this is the histogram. Just stat bins, using bins equals to 30 by default. So I will use the bin width as 40 now, and we'll see the result again. So we can see the similar kind of result, but the spaces are just narrow here. So we have used the bin 40. Like if we use 50 bins, we will even see the narrow lines. And then let's try for 100. So there will be 100 bins. So it's better for the visualization, but it would be so difficult for us to just to know these plots, like they are almost similar and we can distinguish here. Okay, now after this I have also used the markup here, and in this we have used the muted functions combined with the chord to split it into the three bins. So let's see the output here. Like there will be only the three bins here, 1, 2 and 3. Yeah, so it will be so understandable. Like from 305 to 342 elevation, the count is less than 50,000, no, 500,000. And for this elevation, the count is this, and for this elevation the count is this. So if you want to know the cutoff values for the group, we can ask for the unique values of elevation. So for this we will introduce the unique function, and we will go to that data frame, and we will use the elevation of that data frame. We can use in the dollar sign for this. So we enter this and we can see the unique values. Okay, now we can get the count of values in each group by using group by function and count functions. So this is a group by function. The elevation will be grouped and it will be counted. Like all these elevation, like 305 to 342, there will be the exact amount. Like I have told it as 500,000, less than 500,000. So there will be the exact value, the integer value, like 41 418,000, and these are the values. Like, and if we would like to look from the range of elevation 342 to 379, we will see the range about above the 115 lakhs, 1 2 3, yeah, 15 lakhs. So we'll see here more than 15 lakhs. So and these are the things we can visualize in this thing. So I will just use this now. We might prefer to customize the cutoff frequency for these groups. Let's round off the cutoff values so that we have the groups for the range. Now I will change the range from 301 to 350, 351 to 400, and 401 to 450. Not like this one. It has break up the cutoff by using its own internal method, but we are telling the system to cut off these things in these bins. So let's see. We will use the custom bins, and the custom bins will be from this to this, this to this, and this to this. There is the bins like 300 to 350. 350 to 400, 400 to 450. Yeah. So here is a tip. So note that when we assign breakpoint, a set of 4 values will result in 3 bins of data. Okay, like these 4 values, 1 2 3 4 4 values will be set up in the 3 bins of data. So the bin intervals are showing using two min exclusive and this sign and this sign. Yeah, for example 300 this sign and 342 this sign means that it will not include at 305 but it will include from 306 to 345, but 342 will be included but 305 will not be included here, 306 will be included instead of 305. So now we are going to plot the bar. So let's see what we can see. You can see this kind of things, like the graph has been changed drastically from this kind to this kind by using these ranges of elevation. Now we can also then get the count of these things, like from 300 to 350 we have the count up to like 74, yeah, 74 7,41,815, and from 350 to 400 we will see this range, and from 400 to 450 we will see this range. So these are the outputs. Now we can use these groups to plot our raster data with each group belonging to different color. So code quick map will use the color for this, and the raster dataset will be plotted in the ggplot, and the x coordinate will be x coordinate, y coordinate be y coordinate, and the fill will be according to the height. So let's play this and we'll see the result. It will take some time. Yeah, this is the result. So these are the elevation, like we have decided the values of range of the bins from 300 to 350, 400 to 350 to 400, 400 to 450. So these are the x and y coordinates here of our raster data, which I had shown in this the tutorial before this video. So we can see the map here. So after this, the plot above use the default color. This is default color, and we can specify the nicer color. So the terrain color will be of the 3 palettes. So we can use 3 palettes, as well as the 3 palettes will be the colors like this one by default. Okay, now if I use the 4 palettes, there will be 4 palettes. If I use 5 palettes, I can see 5 palettes. So if I use 5 palettes here, we can see the difference here than this one. So let's see the difference here. Okay, we have used 1 2 3, but only 3 colors are shown. The terrain dot colors result the hex color. Each of these character string represent a color. Okay, this might be because of we have decided to use only 3 bins. If we use 4 bins, we can do that thing also. So I will use just 500 to check if it will work or not. So 354 500, yes. Now I will use this one. I will enter this one, but I can't see here 500. So I will have some problem here, not showing in the custom. mm, let's see. I have uh, run it all. Just wait for a minute. So I did something by pausing this video, so I will show you what I did. So from here I break the point at 4. It was 3 before, so I break it into 4 breakpoints. Now I just remove underscore 2, and I use the same elevation. So there are the 4 different points or bins. So I have now used this one, and I can see these things over here. And I removed all underscore 2 here and only used FCT elevation, and there are 4 bins. Now there are 4 bins. So when I fill with this fact elevation, I can see the 4 bins like 1 2 3 4. Yeah, and I use the color terrain 4. There are 4 colors, and I just hit enter. I hope, oh no, here 4. So I hope the 4 colors will be seen in our output. I had the same mistake, like I did not remove the underscore 2 here, so shift enter. Okay, I can see 4 colors now. Okay, then after more plotting formatting. If we need to create multiple plot using the same color palette, we can create an R object, my column, for the set of colors that we want to use. Okay, then this is my column is called, and the terrain dot colors will be 3. So I will again use this as a 4, and I will remove this. So shift enter. We can see the output with the 4 colors again. So the 4 colors is not the point we are going to tell, but we are what we are going to do is the visualization by using the elevation. So we are using the DSM data, and we are visualizing it. Okay, now or we can also turn off the labels of both axes by passing elements underscore blank to relevant part of the theme function. So where we had used this blank here, so axis title, there will be no title in the output. I hope we have this title x and y. So x and y has been disappeared. So there is only 3 colors because I have used the fct underscore elevation 2 as my fill, so it's not a problem. Now challenge plot using custom break. So how can you plot the diagram using custom break? So the challenge is that create a plot of Harvard Forest and digital surface model that has 6 classified ranges of values, breakpoints that are evenly divided among the range of pixel values, axis levels of plot title. So there should be plot title, axis values, and all these things. So for cutting it into the 6 breakpoints, we use the breaks as 6, and also we use the color 6 colors directly, so the output will be of the colorful and will be made up of 6 colors and 6 breakpoints, and the fill will be used as a fact elevation underscore 6, the and the fct underscore elevation 6 will be assigned by like this variable will have the value of this one, so there will be 6 bins or 6 classes. So we use scale fill manually, and the values will be my goal, so this is the colors, and the name will be elevation. Okay, and that is the name of the legend. Now gg title means the title of this figure will be this one, and the x-axis will be this one, and y-axis will be this one. So after calling this code.quick map, we will see the output of this figure. Okay, we can see the output as 6 color bands. So these are the outputs, and we have got the title over here, x-axis, y-axis, and this elevation title. So thank you for watching, and keep subscribing my channel, and I will be back with some good more good tutorials about the R programming and remote sensing data. So bye for now.